All right, so we have this. I'm sure if you're playing tennis, this is exactly what you're doing to calculate all of this out. I enjoy these kinds of problems. They're kind of fun, but I don't know. You may or may not. You can try this on your own. This is an example. It's in the book, page 363, so that it has the steps in the book. I'm going to go through them. I don't know if I'm doing it the same way as the book. I haven't actually looked at that yet. So while playing tennis, Matt is 12 meters from the net. So the distance from Matt, this is Matt, to the net, this is net, is 12 meters. Okay, that's the distance between the two. The net is 0.9 meters high. Got a nice label on the net, 0.9 meters. And he needs to hit the ball so it just clears the net. So it's going to be right about here. It's going to roll over the top of the net at 0.9 meters high and land 6 meters beyond. All right, so what we have here are similar triangles. And when we have similar triangles, the proportions are the same. Okay, so what we can say is, looking at this smaller triangle up in the front, this triangle up at the front, we know that the net is 0.9 meters high, and the distance from the net to where we want the ball to land is 6 meters. So we can actually say, we can set this up as a proportion of 6 meters, that's the distance from the net to where the ball lands, over 0.9 meters is equal to the distance from Matt to where he wants the ball to land, which is 18 meters. Okay, so this distance right here, that's not going to come out right. This distance right here plus this distance right here, try that again. Those two distances combined are the full distance of that bigger triangle is what we're looking at. Okay, so 18 meters over some height that we don't know. And you should hopefully remember this from a long time ago. I know for some reason people love to do this. You're going to cross multiply here. Okay, so 6m, we're going to cross multiply these two and reset our equation. So 6m times h gives us 6, actually let's leave the m's out, 6 meters times h, so we have 6h, and then we have 0.9 times 18, which is 162. 162? 16.2 probably. Okay, so that would be 90, and that is 72, which is 162. Yep. So 16.2. So we need 6 to go into 16.2. We're going to divide both sides by 6. And calculators are okay. 16.2 divided by 6, 2.7. So the height where he needs to hit the ball, this height right here, needs to be 2.7 meters. Okay, so that's fairly close to, let's see, 2 meters is about 6 feet. So add another meter. It's a little bit less than 9 feet, probably between 8 and 9 feet. Okay, so 2.7 meters is where Matt needs to hit the ball. Okay, probably talked too much on this one.